This video is brought to you by our amazing supporters over at Patreon. Hey everyone, it's Ben from Board to Bits, and in this video we're going to be talking about our building renderer script. I'm going to be doing something a little bit different in this episode. Instead of walking you through as I write the code, I'm actually just going to start with the finished code, which is going to be available. There's going to be a link down in the description so you can download it and follow along, and just kind of talk through what I was doing with it. A big reason for this is I actually recorded this video the way that I normally do it, writing the code out and talking through it, and it was close to like 45 minutes long. I was hitting typos just because there was so much code to write. I feel like this is just going to be a better experience. Also, this isn't directly related to the actual procedural generation. Rather, this is just kind of rendering it based on the particular assets we're using. And that's going to change dramatically depending on the assets that you end up using for your final game. So I just, rather than kind of going through step by step like that and taking a lot longer, I'm just going to kind of dive in, show you what I did, show you the thinking behind it, and then you can kind of adapt that to your project's needs. So first thing that we do need, though, in order to render these assets is we need some assets to show. And so I'm using the kenny.nl medieval town set. If you go to kenny.nl/assets/medieval town base, which you'll see up here, I'll put a link to this in the description as well. You can access this. I've seen on Twitter that it looks like he's working on a kind of reboot of this set, but for now we'll stick with the original one. Okay. So once you have that downloaded, you can import it pretty easily. Just go to your assets folder. I've already got it here, but I'll show you the steps. You can just go to import package, custom package, and you're going to find where you installed that folder of his. It's just called medieval-town-kenny by default. And then in there's going to be a folder called Unity package, and there's a nice Unity package file inside of there. You'll just click that, hit open, and that will import everything directly into your assets root folder. With that, then you'll go over to your scripts folder, and you can create a C# script called building renderer, which I have here, and this is the one that I've worked on, or you can simply import this if you've downloaded it from the description below. And so this is the file. It's a pretty long file, and basically what it's doing is it's kind of following that grammar structure where it's starting off saying I'm going to render the entire building, and then that building iterates through each of its wings. The wings iterate through each of their stories and figures out ultimately what it's going to render. And it's rendering three types of objects. It's rendering floors, it's rendering walls, and it's rendering roofs. So the first thing we have up here we'll see is three public variables. The first one is a floor prefab. I'm always just using a wooden floor, so I don't have multiple options for that. For the wall prefabs and the roof prefabs, I'm using arrays of transforms. This is because you may recall if I go to, say, my wall class here, we see that we have three different types. We have an empty wall, we have a wall with a window, wall with a door. And so what's going to be nice about having these arrays is that we can really just kind of reference based on, say, if I have an index 0 empty wall, I can reference index 0 of the array to get that. And same for the roof prefab, so we're going to have access to all of those. I also have a separate transform called building folder, which is just going to be where kind of in the scene hierarchy, there's going to be an empty game object that kind of stores the root of this building. I'm calling them folders, but they're really just the empty game objects that you can use for organization in your scenes. So the first thing we have here is the render method. And all that this render method does is it takes in the building, and this is the product, the data structure product of our building generator. Takes that in, it creates a new transform for the building folder, so that's just going to drop that into the scene. I'm going to call it building. And then for each wing in our data structure's wings parameter, we are going to render a wing. The render wing takes in that wing as data, as a parameter, and we create now a separate folder called wing folder, and it's just named wing, and that gets childed to, or it's set with the building folder as its parent. And then for each story within the wing, we render the story. So you can see there's sort of this almost recursive loop going on of for each element inside of this particular structure, we're going to iterate through. For each element inside of that element, we're going to iterate through. In addition, however, for the wings, at the very top of each wing is going to be some specific type of roof. So regardless of how many stories we always have one roof at the very top. And in each case here, we're passing in, so for the story, we're passing in the story itself. We're also passing in the wing because we need some information about the space that the wing takes up. And we're going to pass in that wing folder so that we can also create another folder underneath and continue doing the child process there. Likewise for roof, we need the wing again because we need that spatial information, where the wing stops, where the wing ends, and that wing folder for hierarchy purposes. So render story is where things start to get a little bit more complicated, because here now we're not just looking at iterating through individual stories or individual wings. We now need to go through each possible square within the space of the building and see, is this part of the wing? And B, should we have walls around this square? So the first thing we do is, again, we create a story folder. We set its parent to the wing folder. And then we start going through, like I say, each kind of square in the grid system of this wing. So we start off at the minimum of the wing, and then we're going to go all the way up to the maximum size of the wing, technically one less than the maximum size, and iterate through, and then do the same thing on what we're calling, I'm calling it Y because the bounds they're vector 2s or int vector 2s, so they deal in X and Y. Technically this is going to be the Z axis of our world space, but that's just a little bit of a thing that doesn't line up quite perfectly, but I'm working with Y because that's what a lot of the vector 2s work with. So the first thing we do, we always, as long as we're inside of the wing, we're going to place a piece of floor down on that square. We know there's going to be a floor there. So we're going to call this place floor method. We're going to get the X and Y position. We're going to get the story level so we know how high up this is supposed to be. And we're going to give that story folder so we can store that in the hierarchy. From there, we need to check each side of this to see, should there be a wall here? So if it's on the south wall, meaning that it's on the Y bounds minimum, then we're going to put a wall on that south side of it. How we check what type of wall is, we need to go into, if we go to my story class here, we need to go to this wall array, which is basically a list of integers, or a list of wall types, i.e. these things here, this enum, to say, this one's empty, this one's a window, this one's empty, this one's a door, this one's empty, this one's empty, etc., etc. And how we basically envision this is that the start of the array is the south wall, going kind of from the southwest corner heading east, and then from there once you get to the southeast corner, you head north to the northeast corner, and then you kind of do a counterclockwise loop around the square. So back in our building renderer, what we're doing here is we're saying the type of wall that we're going to put in this case is going to be from our wall prefabs. We're going to look, and we're going to basically go into our story, go into our walls array, and so what this is doing is getting the X value, so this is the X value in the entire building's space, and then subtracting from it the minimum X bound. So basically what this is saying is that if the wing doesn't start until, say 2 units in, then if this is 2, that means we're at the very start of the wing, so we need to make sure we're always offsetting for that minimum. So this would get us, in that case, the very first element of the array, and would look there for what this south wall should be. And then we convert that value into an integer, because this value is going to be a 0, a 1, or a 2, and once we convert it from the enum, and then we can use that to get the proper prefab from the wall prefab. Then we're going to call another method called placeSouthWall, using that particular type of wall that we have, along with the X position, the Y position, the level, how high it should be, and the hierarchy folder. And then basically, we're doing the same thing. And then basically we're doing the same thing for each wall. For the east wall, we're checking, are we basically all the way on the far east side of the building? And we're going to get, basically, we're going to go along the entire south side of the wall, which is this size.x. We're going the entire way along there. And then we're going to the, going up the east wall, and so we're checking the position there. Same thing for the north wall. We're checking, are we at the maximum kind of size of are we on the top side of this wing? And then if we are on the top side of the wing, then we're going to go along both the south and east walls, and then we're going to get the position on the north wall, and the same thing for the west wall. If we're all the way on the west side, kind of the left, the minimum X side, then we are going to go along all 4 walls to find the right type of wall that we're getting. And so once we've done all of those, we may have 1 or more walls around this particular square of the building, and then we will place each of those. And we're doing this each with their own method right now, mostly for kind of clarity's sake and ease of working with them. However, it would be more efficient to kind of create just a place wall method. And I can show you further down, we're going to talk about place roof, where that's kind of being treated a little bit differently, and how you could kind of convert these into a single method. So for place floor is pretty straightforward. Again, we have the X position, the Y, which is technically the Z position in the world, the level, and the transform for the hierarchy. We're just basically going to create a transform that we're instantiating, which is of the floor prefab, which is only ever the wooden floor. We're giving it a position, and the position is based on this story folder transform point, which basically means that I want it to be oriented based on where the building is itself, not just the 0, 0, 0 of the world. So that's why I'm making sure to do transform point, and then I'm giving it this particular vector 3. And this vector 3 deals with the particular asset pack that I'm working with, which is that the size of the walls and like the roofs and stuff are all based on a 3-unit square. So the wall is 3 units wide. And that's why we'll see that there's a lot of multiplying by -3s here, because basically if it's offset by 1, you need to actually multiply that by 3 to have it line up properly. So we have our X position times -3. We have our Y position times -3. In addition, with a floor and a wall stacked together, that's a height of 2.5. So every level above the ground floor that you need to go up 2.5. For the floor, we're not rotating, so we're just using quaternion identity. And then we're setting that parent to that story folder. And here we get to our wall placement methods. And so for each of these, we are taking in not just the positions, height, and hierarchy, but also the type of wall. But then from there, we're doing roughly the same idea. We are still instantiating that particular wall prefab, and we're also putting it at that transform point, but these are going to change based on the position. If it's at the south, then we need to make sure that we're offsetting based on the thickness of the wall, and we are also rotating at 90 degrees. For the east wall, we are offsetting by this -0.25 to move it to the east side of the square, and we're just keeping the quaternion right on the default. For the north wall, we need to position it another 3 units up so that it's on the northern edge of the square, and we're rotating again by 90 degrees. And then finally for the west wall, we're just keeping it in that base position and the base rotation. That one's kind of the default location. Next, we have to render our roof. And so for rendering the roof, same idea. We're taking in the full wing information so we know where the wing starts, where the wing ends. We're giving it that wing folder for the hierarchy. And again, we're iterating through the entire wing, and in each square, in this case though, we're not ever checking. We don't need to check should there be a roof or not. We're going to always assume there's a roof, and we're placing that roof at that X and Y position. We're going to place it at the total height of the building. So if it's 3 stories, we want to make sure that we know it's 3 versus 2 versus 1 story tall. So we're passing in that information, we're giving it the hierarchy information, and we're giving it both the type and the direction of the roof. So when we place the roof, we again are just instantiating a prefab. So we're giving it we're saying R here, and then we're getting the prefab that we're going to actually do. In this case, we're doing it inside of the method. We're getting roof prefab of integer type. So basically we're taking the type that we have in our roof enum here, 0, 1, 2, 3, converting it to that integer, and then that's how we're able to get the proper index of our roof array. We're doing, again, the transform point. In this case, it's very similar to the wall. However, we are, in this case now, instead of worrying about, east wall, north wall, west wall, we do have to worry about the directions, because if we're rotating a roof piece based on its direction, then we do need to offset things. In this case, we're doing this a little bit differently, though. Instead of saying, 4 different methods for it, I created this array of vector 3s down here. And what this array does is we have a X offset that's positional. So in this case here, if you're facing, I believe it's north. Oh, that's maybe, actually, let's just look and see. Yep, north. Then you're going to be offset -3 on the x-axis, and you're offset 0 on the z-axis. And then this 270 here is your rotation on the y-axis. So it's a little bit, there's position, rotation, position, but it is x, y, and z in the world space. So it does make sense to have these all together and all here in one. It's kind of convenient. And so then what we can do is I can say here, instead of having to create 4 different methods, I'm saying here, do the -3 by default, and then you're going to do this rotational offset based on that direction that it's facing. Same thing here, we have a little bit of, we have one thing that we need to do, which is that we're still doing that level times 2.5, so that we're going up the appropriate number of stories. However, the point roof has a little bit of a different shape than the others, so if you did it the full 2.5, it would actually have a gap. So if it's the point roof, we need to actually then drop that back down another 0.3. Otherwise, we can just keep it at the level times 2.5. And then same thing for rotation offset for the Z position. Again, this is labeled as Y here because the vector 2s often deal in X and Y, but ultimately this is going into the Z position of the world. And then finally, rotation, again, if it is facing, I believe that is east. Yes, if it's facing east, then we don't rotate at all, but the other 3 positions we have to rotate at some value. And then finally setting the parent. So with all that in place, this actually gives us everything we need. We're able to place all of our walls, we're able to place our floors, we're able to place our roofs, and we can now add this into our scene. So when you want to actually implement this into the project or into the scene itself, what you'll do is you'll take your building demo object and you will add this building renderer to it. This will give you a component that looks like this, and you'll have a number, you'll have 2 empty arrays here, and you'll have this full or prefab. So if you go into the medieval town, and you'll want to lock this inspector here so you don't lose this as you're kind of searching for your objects. You can either simply go through these and find the ones that you want to use, or you can actually use this search bar up here. It can come in very handy in a situation like this where you have a lot of objects to choose from. So for example, I know my floor I know is going to be the plate wood. I can just type in plate here, and it will narrow it down to those, and I can find the one that I want. It's going to be the ones that you see with the picture. You don't want just the mesh of it, and I'll just click and drag that into here, and that'll give me the floor that I want there. For the walls you will need to say wall. For the plain wall, you'll need to just say wall, and you can grab that here, put that into the first position, and you want to make sure that these line up with your enum. So you want the first one to be the empty, the next one to be the window, the next one to be the door. Otherwise, you're going to not get the results that you're looking for. For the window and door, they don't have the word wall in them, so you would need to type in window here, and you'll get all the different windows. Door here to get the doors. And then like for the roof, you can just type in roof and you'll get all of them. I chose the green roofs for these because I'm using the wooden walls as well with like the wooden posts, and the green roofs have those wooden posts with them. You can use the red ones too, but just know that they have kind of the stone post look to them, so they will look a little bit different if you stack those on top of the wooden framed building. But with all those placed, you have the point, the straight, which is the point here, the straight kind of A-frame roof, the slant, and then finally the, for the flat roof, I did not use a roof, I used a paver. So if I go back to plates again, you'll see that I used the pure pavement roof for that. So that's going to give it like a gray flat roof in those cases. And that gives us everything we need here to actually now run our building. However, we need to actually call this somewhere. Right now we're not, we have a public render method, but we're not calling it. So you'll need to go into building demo, and if you open up your building demo class, you'll see here what I've added is just this one line here, which is to get component building renderer, and this only works if that component's on the same object. We'll talk about kind of extracting that out later. And then you have to call .render, and you have to pass in that building that you generated. in the previous line here. I'm still printing out the string too, just for debugging purposes, but that gives us everything we need to be able to actually see our building. And with that, what we can do is we can go back to Unity, and now when we hit play, the building demo will call the renderer, and it will create our building for us. You can see the camera is kind of lodged in the building at the moment, but we see that we get our 4x4, which is kind of what we've hard-coded our building to be. It's got our peaked roof. However, the peaked roof right now is not kind of what we would have probably expect. We would probably expect it to be one very large peak, not these kind of 4 individual peaks. That's something that we'll kind of finesse later on. And we're also getting all of our appropriate walls. If we kind of go into the building a little bit here, we should see that, yeah, we're not creating walls every single square inside of here, just the 4 edges of the wing itself. And now, obviously, right now, we can only create this one building. If I stop it and start it again, it's always going to be this one building. It's not really procedural in the sense that we're creating a unique building every time. And so in order to do that, what we're going to get into in the next video is actually taking the kind of hard-coded single-story, single-wing building generation that we're doing right now, breaking that out into its different constituent methods to create the different pieces, and be able to use that to start customizing what our building is going to look like. In the meantime, thanks for watching. If you've enjoyed this video, please consider liking and subscribing down below, and also consider becoming a Patreon supporter if you want to get early access to code and other sneak previews on occasion that I'm able to do. Other than that, I'll be back in a couple weeks with the next video. Thanks for watching, and I'll see you next time.